we're always able to work with anyone within the value chain. It's kind of funny. This is one of the great things about being on board. It doesn't matter how difficult some of the discussions or some of the conversation is around the board table. We're always able to go and have a beer afterwards type thing, because we got to support the barley industry, right? And I think everyone sort of enjoys that, and the fact that we can have different opinions, but it's still very respected opinions on both sides. We bring a lot of just kind of some basic common sense and basic sort of, well, what makes sense for producers today?
Welcome to the Barley Bin. SaskBarley's goal is to take you right into the barley bin, not a hopper bin or a bin with in-floor augers, but the kind you'd spend a bit of time shoveling, getting itchy. It's worth it for the pint or steak afterwards, or a golden nugget you sometimes find uncovering itchy topics.
I'm Mitchell Japp. Season 3 is now well underway, starting with a special mini-series on disease management. Join us as we dive in and get itchy in the third and final episode of the mini-series, but keep listening for the rest of Season 3. Let's start with a quick recap from the last 2 episodes of the mini-series. So far, we've traced how barley disease research in Western Canada evolved from its early roots in the 1980s and 1990s through the turning point brought on by Fusarium head blight in the early 2000s. In this final episode, we bring the story into the present. Because today, barley disease research looks very different than it did even 20 years ago. The questions are more complex, the tools are more advanced, and the expectations from farmers, industry, and markets are higher than ever. Today's barley disease programs across Saskatchewan, Manitoba, and Alberta are focused on a shared goal: helping farmers manage disease risk under real-world conditions while staying ahead of emerging threats. In Saskatchewan, much of that work runs through the University of Saskatchewan's Crop Development Centre, where disease resistance is built directly into barley breeding programs. Pathologists and breeders work side by side, screening lines for disease response, while also selecting for agronomic performance and quality. In Alberta, research at the Agriculture and Agri-Food Canada Lacombe Research and Development Centre, and through Western Crop Innovations, focuses heavily on applied disease management. Field-based screening, fungicide timing, agronomy, and integrated systems that can be directly adopted by farmers. And in Manitoba, Agriculture and Agri-Food Canada's Brandon Research Centre plays a key role in disease surveillance, regional monitoring, and prairie-wide coordination, especially when it comes to Fusarium head blight. This distributed but coordinated structure reflects an important lesson learned over decades. Disease does not respect provincial boundaries. As such, researchers in Western Canada have increasingly worked together to tackle these big issues with coordinated responses. But despite the advances we've made in recent decades in barley disease research and management tools, diseases continue to thrive and bring new challenges. So what does the barley disease research community actually focus on today, and where is that work headed next? Across Western Canada, researchers say the priority is no longer any single disease. Instead, it's understanding how diseases behave within whole farming systems and how those systems are changing. Dr. Kelly Turkington, a plant pathologist at AIFC's Lacombe Research and Development Centre and one of Canada's leading experts in the field, says one of the biggest challenges is that diseases are constantly adapting.
These things are not static. They will adapt to the varieties that a grower uses, the rotational system that they're following, and then any of the pesticides that we're using.
Because of that, today's research continues to put strong emphasis on integrated disease management, combining genetics, agronomy, rotation, and fungicide strategies, rather than relying on any single tool. Going forward, this approach will be boosted by modern molecular science.
We need to recognize the importance of a combination of approaches. My background is in plant disease epidemiology. I work with colleagues they bring the molecular or genomics perspective. Marrying the two together and not focusing one at the expense of the other, I think it's important to look at the combination.
Another growing focus is on what's happening below the soil surface, an area Turkington says has been understudied but may play a major role in future productivity.
One issue that I think it's more of a challenge, and it's out of sight, out of mind, is root diseases.
Root health is closely tied to water use efficiency, nitrogen uptake, and long-term resilience, especially as climate variability increases. At the same time, researchers are keeping a close eye on emerging threats. While many disease pressures today look familiar, tighter rotations and renewed interest in barley mean risks are increasing. Dr. Randy Kuchar, a pathologist at the University of Saskatchewan and another of Canada's leading experts in the field, talks about what he sees are the current risks for barley.
Right now, more of the same,
Okay.
leaf spots. Barley acreage is going up again. So if folks are growing it a little more intensively, probably more leaf spots.
He also points to FHB as a persistent challenge, particularly for malting barley.
The maltsters do not want any fusarium in their barley.
Looking ahead, Kuchar says researchers are also watching closely for diseases that have caused problems elsewhere in the world, like stripe rust and ramularia, that could eventually appear in Canadian barley crops. In light of these challenges, Kuchar says a foundational approach to integrated disease management is more important than ever for farmers.
I would still say that, the three best things growers can do is a diverse rotation, choose the best resistant variety, and then if that is not enough, factor in a fungicide.
But he also emphasizes that modern tools only work if they're grounded in real field data.
All the molecular markers you have aren't very helpful if you don't have good phenotypic data.
That's where new technologies like imaging and AI, artificial intelligence, come in. And this is an area that holds much opportunity for the barley disease research world, experts say. In fact, one of the biggest drivers of change in recent decades has been the adoption of new technology into Western Canadian research and breeding programs. Dr. James Tucker, a research scientist focused on barley pathology at the Brandon Research and Development Centre, says that one of the biggest drivers of change in recent decades has been the adoption of new technology into Western Canadian research and breeding programs.
When I first started back in 2001, there was very little molecular marker that you had access to in barley, and now it seems like the sky's the limit, and then those limits are now affordable. I think that's been a huge impact in the last half a decade or so in how we're doing things here. We can do these genetic studies and use the information for better breeding.
Genomics, molecular markers, and DNA-based tools now allow researchers to identify resistance traits faster and more precisely, accelerating progress that once took decades. This technology hasn't replaced traditional pathology, it has strengthened it, says Sheila Andrade, a graduate student at the University of Saskatchewan. She says that being a modern plant pathologist means working at the intersection of field biology and advanced imaging. Her thesis project, which has been supervised by Kuchar, reflects this.
We are trying to use advanced image technologies to detect fusarium damaged kernels and try to correlate this damage with the mycotoxin contamination. What is done now is visual assessment. It's subjective. Some of the kernels don't show the usually symptoms, the common symptoms, but they are still contaminated with the mycotoxin. And this is like a huge problem.
Andrade's work highlights a major opportunity ahead: earlier, more accurate detection of disease and mycotoxin risk, tools that could improve food and feed safety and speed up breeding for resistance. In her opinion, the future of barley pathology lies in earlier detection and better prediction.
Besides the damage that we can see on the kernel, be able to see the mycotoxin or to predict the mycotoxin, it's an exciting thing to accomplish. So I'm really looking forward and try to get this kind of technology to help the industry, the breeders, and plant pathologists.
She believes these new tools, based on imaging and AI capacity, can speed up progress towards improved resistance and safer grain. She also believes they can deliver portable and practical solutions for breeders and farmers in the fields.
Our first goal was to test if this technology works. And now that we got some good results, the next step is to try to adapt this X-ray in a benchtop machine. That will be easier for breeders and also even for the industry or for the elevators. I think it will have a great impact on the food safety.
Andrade's excitement for the future of barley research is also important, as it will be up to her generation of young researchers to carry the work forward. This transition is on the minds of many of the field's current leaders, including Kuchar, who is also a professor at the University of Saskatchewan's College of Agriculture and Bioresources, as he nears the end of his career. In fact, over the last decade, he has made training the next generation of plant pathologists a core focus of his program. He uses his undergraduate teaching as an opportunity to spark interest in disease management and guide graduate students into applied, field-based research careers. And he says there is a strong interest in these programs, especially from students overseas.
There's no shortage of international students that want to come to U of S. I probably get 3 or 4 emails every day of
Really?
around the world that would love to study here, right? It's
Okay.
a little harder to get Canadians to go to grad school, but a master's degree opens a lot of doors.
Kuchar says he also learns an equal amount from his students, many of whom come from farms.
I learn a lot from my students. What
Cool.
happened on your farm last summer? You know, how did you manage Ascochyta blight in your chickpea? How many times did you spray? And what varieties did you grow? And, you know, all those kind of questions we'll start a discussion on. So that's where I learn.
Kuchar's passion for collaboration with his students comes as no surprise, as he and Turkington represent a generation of researchers whose careers were built on close collaboration with each other, with farmers, and with industry. They are both quick to credit others for any successes they've had throughout the years, and to always list the names of anyone else involved with their research when it's been recognized. They also both give credit to the researchers who came before them and helped guide them throughout their careers.
That mentorship over the last 40 years, that's really helped me as a scientist, but also in terms of the work that we do to help address production concerns that producers have.
Turkington also says one of the most rewarding parts of his career has been working across the entire barley system, alongside technical staff, fellow scientists, breeders, crop consultants, producers, commissions, and maltsters, to solve real-world problems. In fact, he lists these collaborations as a career highlight.
First of all, the people that I've worked with, I can't emphasize that enough. It definitely hasn't been a one-person show.
He's also especially proud that his research has always been a two-way street, shaped as much by what farmers see in their fields as by questions coming from the lab.
That flow of information from the field level through the farmers and crop consultants has been critical. We've learned as much as we've passed on to producers.
Kuchar's career highlights also come down to people.
Talking to growers, that was one of my favorite parts of the job, getting called out to fields and being part of the community. You see problems in the field and you want to do something about it.
He's also proud of his decades of applied, field-based work that helped refine disease management recommendations for farmers, especially around fungicide timing and integrated approaches, which was always done in collaboration with colleagues like Turkington. And this work has definitely made a lasting impact on the barley industry, with farmers increasingly seeing the value of their investments into research and variety development. In fact, Zenith Fay, who has been growing barley for decades near Foam Lake, Saskatchewan, says he believes this research is more important today than ever before. As Fay also nears retirement, he reflects on the fact that farming today is much more complex than it was in the past, with rising input costs and tighter margins. Another ongoing pressure in the barley world, he says, is the slow end-user acceptance of new malting varieties, even when genetics and disease resistance improve. In light of all of this, research matters.
It's gotten more complicated. The dollars have also been a more challenging.
but we have more tools in our toolbox.
Faye has served as a director for SaskBarley, where he has been heavily involved in making strategic decisions about research investments.
We spend a lot of time on trying to prioritize what the best bang for the dollar of investment is.
Because of this, he says he knows that research-driven gains in varieties, agronomy, and disease management are what keep Canadian barley competitive. He also believes that farmer investments in this research are critical.
Definitely varietal development with new traits that are good for agronomic, but also good for the end user. Those are all extremely important.
Looking ahead, the future of barley disease research will focus on resilience, adapting to climate variability, improving predictive tools, continuing gains in genetic resistance, and training researchers who can work across disciplines. The diseases will change, the tools will change, but the core challenge remains the same: growing healthy crops under uncertain conditions while keeping farms viable. And one more thing will continue to drive these efforts forward: the care and passion of researchers, new and old, who dedicate their careers to these same goals. Thank you for joining me for the third and concluding episode of this mini-series on the development and advances in disease management. But Season 3 of the podcast isn't over yet. I'm Mitchell Japp, and this has been Episode 3 of Season 3 of the BarleyBin podcast.
Thanks for listening to the Barley Bin. Rate our podcast, subscribe, and tell a friend to tune in wherever you listen to podcasts. Brought to you by SaskBarley, because it's time to get in the bin and get itchy.
Produced at
Sound Lounge by T-Bone.